Okay, so this is your Exam 9 review, and obviously this is the first time that I've done one of these, so, bear with me. It's probably going to have a few kinks, and depending on how much time I have to retry this, or how many times I have to do it, I might not be able to redo it. So I want to go through this, trying to draw out these problems using a laptop since I don't have a trackpad type thing yet is going to be a little bit difficult. But I want to go ahead and go through this. I would say take out your study guide because I'm going to be using that as a review for you to kind of piece through this. And also I would take out a piece of paper so you can try to work things along with me as I go. One thing that you have to know for the test is you need to know the difference between Aufbau, Hund, and Pauli's exclusion principle. So basically what you need to know is you need to know that for Aufbau, he said that you need to fill the lowest energy level first. So what I'm talking about, and I'll kind of bring it in when I'm also talking about orbital diagrams because that's the easiest way to see it. But basically, we talked about S block and P block and D block and F block. You're going to fill that 1S first. You're not going to go out and fill in the D block first or 3D or 4D before you do 1S. Likewise, you're not going to do 2S before you do 1S. You're going to follow the pathway that we learned about and kind of going down that yellow brick road of the periodic table. Pauli's exclusion principle, I highly recommend you kind of think about this one for the test. Remember that that's basically saying that there's 2 electrons per orbital, so each orbital holds 2 electrons, and they tend to have they're going to have an opposite spin. What that means for you is that there are no 2 electrons. What that means for you is that there are no 2 electrons that have the same 4 quantum numbers, because no matter what, even if they're in the same orbital, they have a different spin number. Okay, so definitely know that part. And kind of a side note, for this video, the great thing is if you didn't get what I said, you can rewind. Okay, so think about that as you're going. And then Hund's rule, basically it's just saying half fill all the orbitals of a sublevel before you completely fill them. So if you're filling your D block, you're going to put 1 electron in each orbital before you put 2 electrons in an orbital. And once again, I'll kind of go over that a little bit more whenever I go over an orbital diagram. Okay, so orbital diagrams. Let me switch here to a pen. You need to be able to draw or recognize an orbital diagram from various atoms. So here I've put on a periodic table that shows your S block, your D block, your P block, and your F block. What you need to be able to realize from that is the order that you're going to go in. So kind of follow this cursor here. You have your 1S, 2S, 2P, 3S, 3P, 4S, and then you start 3D here. So that's the first thing you need to remember. You also need to remember that an S block, okay, so your S block, this is terrible, has 1 orbital, okay, so that means that it has 2 electrons. Okay, and likewise you need to be able to do that for your other blocks. So you have a P block, a D block, and you also have an F block. Okay, so your P block is going to be 3 orbitals for a total of 6 electrons because there's 2 in each orbital. Your D block, there's 5 orbitals, so yeah, you guessed it, it's 10 electrons. And then for your F block, there's 7 orbitals, so that would be 7 times 2 is 14 electrons. So that's one thing that you kind of have to remember for when you're doing these orbital diagrams. So if I'm doing an orbital diagram for carbon, okay, I'm always going to follow my yellow brick road. So like last time I said, you're going to follow your yellow brick road. You're going to follow Aufbau's. You're going to follow that Aufbau principle. Okay, and to do that, the first thing that you're going to need to do is you're going to need to start at 1S. And I tend to draw boxes, and we'll see how well that works out for me. And then I label them. So I'm going to start with 1S. And like I said before, 1S can have up to 2 electrons. So I'm going to say up and down. So that is Hund's rule. First I followed Hund's rule in that I did one electron first and then the other. Pauli's exclusion principle is also followed, guys. That's where I'm doing the upspin and the downspin of an electron. So I've covered my 1s. I'm trying to get here to my carbon. And so I'm going to go from my 1s, follow my yellow brick road. Now I'm at 2s. So we said s has just one orbital, and s sublevel has one orbital. And I'm going to fill in my electrons. Sweet. Alright, now I'm going to move on. So I'm going to follow my yellow brick road, and it's going to go straight across here to 2p. Alright, we said 2p has 3 orbitals, so I'm going to give it 3 boxes. So the p sublevel has 3 orbitals. Now I'm going to follow Hund's rule, and this is where you can kind of really see it. I'm going to fill one in each first. I'm only going to go in 2. Okay, because here's 1, 2 electrons in my p shell, in my p block. In my p sublevel, I only have 2 electrons for carbon. Now if I were doing this for nitrogen, okay, so there's carbon. If I were doing the same thing for nitrogen, I would just have my 1s with its 2 electrons, my 2s with its 2 electrons, and then once again I go into my 2p, and it's going to be different. It's a different atom, so yeah, it should be different. So I'm going to have my 3 boxes here for my 3 orbitals, and instead of going in, just follow the mouse here, instead of going in 1, 2 for carbon, I'm going to have 3 electrons contributed by my nitrogen. Alright, so when I draw that, it'd be 1, 2, 3. Okay, and if I did oxygen, if I just cross that out, if I decided to make that oxygen, then I would just start adding more electrons, because now I'm going in 4. 1, 2, 3, 4. So I need 4 electrons in my boxes, and it needs to look like this, not 2 here, 2 here, because that would violate the Hund's rule. And then fluorine, I'm doing it for fluorine, just once again, just adding another one. Okay, so that's how you do a regular orbital diagram, and you need to be able to recognize it. The way you're going to see it on the test is we're going to give you one of these, could be one of these different atoms, and from that element you need to be able to recognize which orbital diagram it belongs to. Okay. So next you also need to be able to do a valence orbital diagram. So when you're talking about a valence shell is only made up of your S block. It's only made up of your S block and your P block electrons. So you're not going to count your D block electrons at all. You're just looking at your S and P electrons. So if I'm doing it for manganese and I were doing my orbital diagram, the only ones that count are my S block and my P block. Okay, so it's going to be 4s and then just like that. Okay, yes, I go in here and I have 5 electrons in my D block, but those are not going to count. Those are not going to count. I'm only going to have these 2 valence electrons. I know that's might sound kind of a little bit crazy, but that's what you're going to see. So you should be able to do that for any of these, and really for all of those, it ends up being the same. So you're lucky there. Next, you can move on to electron configuration. Okay, so we're going to use those same principles that we used for orbital diagrams. One of the big differences for us is that instead of drawing out those boxes and drawing in our electrons in the boxes, we're going to draw our electron. We're just going to write out our electron configurations. 2 ways to do it. You can either follow your yellow brick road, so 1s and there's 2 electrons, 2s, 2 electrons, 2p, and there are 6 electrons that can fill in that sublevel. You can do it that way. The way you're probably going to see it on the test is you're going to see it in the noble gas configuration. So you're going to see it a little bit abbreviated, and it's not going to have that whole long thing typed out. So, for example, if I'm doing it for sulfur, my bad. Okay, if I do it for sulfur, let me get back out of this here. Okay. If I'm doing it for sulfur, which is right here, I'm going to go to the noble gas that comes before it. So I'm going to go backwards here. I go backwards to the noble gas that comes before it. So if I'm going for sulfur, okay, I'm going to go to the noble gas that comes before it. In this case, that's neon. And then I'm going to finish out my configuration for everything that comes after neon. So everything that's on this line that I drew back towards neon, I need to account for in my electron configuration. Well, here's my S block. So I'm going to say this is 3s, okay, because here's 1s, 2s, 3s, 4s, 5s. Okay, so I'm going to say it's 3s, and it's going to hold 2 electrons, because that's how many an S sublevel can hold. Next, I move on to, I go down my yellow brick road, going down my line. I got to 3p. Okay, so now I'm going to write out 3p, and how many electrons are in that p block? Well, there's 1, 2, 3, 4. So I'm going to write a 4 there. And that's really all you have to do for one of these problems. I'll do another one for you, and then I'll let you practice on the rest. Let me do one that might be a little bit tougher, like iron. Okay, so let's look at iron. So I'm going to go to the noble gas that comes before iron. So I'm going to go backwards to the noble gas before iron. That happens to be argon. So if I'm doing iron, okay, I have argon. Here's my noble gas before, and I'm going to put that in brackets. Okay, then I'm going to come backwards, then I'm going to follow my red line, basically what I drew through, go down my yellow brick road, whatever comes after argon towards iron. So I come down, here's 4s, okay, and you remember that S block, the S sublevel can hold 2 electrons. And then I moved into D block. And that's something a little bit new. That's something that I haven't gone over yet in this review. D starts at 3. So this whole row here is 3D. After that I have 4D, 5D, 6D. Alright, so that starts at 3D. Up here you start at 2P. And here you start at 1S. So just kind of reminders on that. So you would say you're in the 3D sublevel. And then you have to count how many electrons you have going towards the iron. So I have 1, 2, 3, 4, 5, 6. So it would be 3D 6. And this is just like the bingo game we played. So if you were able to do bingo, you should be able to do electron configurations as well. If you have any questions on those, then definitely either email me or come in after school and